In this video, we will be learning about acids and bases and what makes compounds acids and bases. This will help support our learning objective for describing acid and base reactions. So what are acids and bases? Acids react in water to produce hydronium ions, which are H3O+. You can remember that hydronium is the positively charged ion because it ends with -ium, like ammonium or sodium. And so that's -ium ending. Acids work by donating H+. That H+ then combines with a water molecule to form our H3O+. Acids are indicated in their chemical formula by H, listed first in the chemical formula. So that's right. H listed first in chemical formula. Bases, on the other hand, they don't form hydronium, they form hydroxide ions in water. Bases are defined as being H+ acceptors. You can recognize bases by either having bases that contain hydroxide ions directly or by bases that contain ammonia or amines. So this is an ammonia molecule here, and how that amine or ammonia is going to work is that there's a lone pair of electrons on the nitrogen that's going to grab a proton off the water, and that's going to form the ammonium cation, and then you'll be left with hydroxide anions. And so ammonia is a base, and so are amines, our organic functional group. Those also behave as bases. So that's how you can form hydroxide ions in solution. Some common properties of acids include that acids have a sour taste. So on your citric acid is used to create that sour flavoring on candy. And then, so citric acid is also found in citrus fruit and phosphoric acid and ascorbic acid and acetic acid. All of these are acids. Bases, on the other hand, have a slippery or soapy feel to them, and bases can taste kind of bitter. They're not generally foods that you would eat straight up. But for instance, tonic water contains a base compound, and then we have Tums, which is calcium carbonate, and baking soda, which is sodium hydrogen carbonate. And then Drano and oven cleaner can contain sodium hydroxide. To compare how acidic or basic a substance is, we can look at the pH scale. pH scale, rather than looking at molarity, it looks at a log of molarity. And so you can see here, this is molarity of H3O+ ions. And so as you get very little H+ ions and more OH- ions, then you will have basic pHs. And so the negative log of 10 to the minus 14 is 14. And so 14 is the max here. 7 is neutral. And then 0 is acidic. So anything between 0 and 7 is acidic. Anything between 7 and 14 is basic. And then 7 is the only neutral category here. You can see that this figure also includes the pHs of common substances, such as household ammonia being a base, baking soda being a base. Your blood is slightly basic, but fairly neutral. And things like vinegar and lemon juice are acidic, and so they have very low pHs. We also have to remember about acid and base strength. Strong acids completely ionize in solution because they are strong electrolytes. So since they completely disassociate in solution, you should use a one-direction arrow to indicate it all went over to the product side. On your green reference sheet, there's a list of strong acids and bases. I've listed those here as well. Primarily, you have your halogens, and then you have group 1 metals and group 2. And so that can help you remember which ones are strong acids and strong bases, but really you just need to memorize it so that you don't have to look it up all the time. Weak acids, on the other hand, do not completely ionize in solution. HF, for instance, even though fluorine is a halogen, it was not on the strong acid list. And if it's not strong, it's weak. So any acid or base not on the strong acid and base list is a weak acid or a weak base. If you put HF in solution, it only partially ionizes. You'll have primarily neutral HF molecules and just a few ions. Other examples of weak acids and weak bases include our organic acids and bases. And so our carboxylic acid functional group, which you'll remember is our COOH, and ammonia and amines. Amines contain a nitrogen bonded to carbons or hydrogens, and so our amine group is there. So if you see any acid indicated by H listed first in the chemical formula, but then its polyatomic ion does not match, that is going to be a weak acid. Also, you might remember that according to our solubility rules, a lot of hydroxides are insoluble. And so if you have an insoluble hydroxide, it's going to be a weak base because it's not even dissolved in solution. So I want you to go ahead and look at your green sheet and try to identify each of the following as either a strong acid, a weak acid, strong base, or strong or weak base. So strong or weak acid or base. Pause the video, work this out, unpause the video when you are ready to continue. Alright, so if we look on our green sheet, HBr is listed. That is a strong acid. So abbreviating strong and acid, strong acid. Next up we have HNO2. HNO3 is on our strong acid list. HNO2 is not on strong acid list. So it is a weak acid. We know it's an acid because of the H listed first. So it's a weak acid. This one is a base. It is on our strong base list. And so it is a strong base. H2SO4 is on our strong acid list, and so it is a strong acid. For our last one, this is a base because of the hydroxide, but it is not on our strong base list, so that is a weak base.